Okay. So because this is a cubing function, our moves from that translation point get cubed. So if I'm thinking in terms of moves, if I go left 2, negative 2 cubed is negative 8. If I go left 1, negative 1 cubed is negative 1. If I go right 1, it's positive 1. Positive 1 cubed is 1. If I go right 2, positive 2. Positive 2 cubed is 8. Let's see if those points are on there. From this inflection point, which is the translation point, right 1, up 1. Left 1, down 1. There they are, guys. Right 2, up 8. There it is. Left 2, down 8. Those are our moves for a cubic function. And those moves are the same from this translation point on every single cubic we do, unless it has a stretch or compression. Now, this one happens to have odd symmetry because this inflection point occurs at the origin. If we shift it at all, left, right, up, down, it no longer has odd symmetry because it has to be through the origin. All right, this made our function go up 2. This makes our function shift down 3. So what we should have noticed is that this number at the end becomes our y. The y value at the translation point. Now, what can we do to make this graph go from this to this? Throw a negative out in front. A negative in front of the function reflects it over the x-axis. Any questions about just this little part? All right, so we kept going, and now we're investigating what happens if I add or subtract something to the x. Well, just like with quadratic and just like with absolute value, it causes a horizontal shift. This one moves right 3 units because we always do the opposite. So that translation point is now at 3, 0. So if we wanted it to go right 3 and up 7.5, we'd need to put x minus 3 and plus 7.5. Okay, now I've highlighted these in pink because when we're doing cubic functions, make sure you're telling me it's a cubic by putting the little 3 there. That's how I know you mean cubic function. All right. So here, how do we find that translation point every time? The opposite of this stays the same, HK. That's how we shift it. Just like we did with quadratics, just like we did with absolute value, we shift the same way. Now, all these are right, but they kind of get confusing when you look at them all together. This is the one that's important.
Those are easy.
Any questions? All right. So, what do these graphs all have in common? That inflection point or the translation point, all for each one of these stayed at 0, 0. It didn't move. And they were all cubics. So they all had that inflection. But in this case, they have vertical stretches or compressions. And some of them had reflections. These that were negative were reflected. So go back to our moves from the first page. These are our normal moves. When we have an A value, when there is a coefficient out in front, these are our A's. So if we thought about this as y equals A times x minus h cubed plus k. This would be the transformational form for a cubic function. These all represent our A's. And with our graph, that A tells you how to multiply your up and down moves. So if the A was 2, we have to come and multiply these by 2. Negative 1 times 2, negative 2. Positive 1 times 2, positive 2. Here it's negative 5. So negative 1 times negative 5 is positive positive 5. This causes it to flip, a reflection over the x. Okay, questions about these two? Well, 15 through 19. Any questions? All right, so this one kind of puts it all together. It's going to be shifted to 2, 5. But now this 3 says if I go left or right 1 unit, instead of going left 1, down 1, I'm going to go left 1 and down 3 because of the 3. The 3 gets multiplied times our y's. So left 1, down 3. Left 1 is 1, down 3 from 5 is 2. This is right 1, up 3. So right 1 from 2 is 3, up 3 takes us to 8. Okay, I'm going to switch this to where it says cubic. I'd like you guys to do the same thing. So if we write this transformational form for a cubic equation, what does the A do? That can do 2 things. If it's greater than 1, it causes a vertical stretch. If it's between -1 and +1, it gives us a compression. So if it's a decimal or a fraction between -1 and +1, makes a compression or a, did you guys use the word shrink? Either words are acceptable. Now, if A is negative, it causes that reflection. All right, now the H part moves it left or right, and the K part moves it up or down. All right, so in this one, this shifts it to 7, -3. These are the 2 points. So what happens when it's 1 unit away? Those moves get multiplied by -4. And because of that, these are our 2 resulting points. So those y, the up and down moves, get multiplied by -4. Okay, so cubic functions, with their transformations, it's just like it was with quadratics. It's just like it was with absolute value. We just have a new set of moves. Our moves, once again, for a cubic, come from cubic. -2 cubed, -8. -1 cubed, -1. 1 cubed, 1. 2 cubed, 8. And these are moves from the translation point. And that translation point is where the inflection happens. Make sense? Cool. All right, there were 2 pages. The second page is homework, but only the front side. We're going to save the back. So this is the side for homework. Are we good? Anybody need me to flip back to that previous screen? Okay.